Hey everyone, over the last two videos we discussed Lewis structures and formal charges, both of which become important to our first new topic in organic chemistry, bond line formulas. Why do we need a specific type of formula to describe molecules when we've been using Lewis structures this whole time? Well, the molecules we often deal with in organic chemistry tend to be large chains or rings and have tons of different elements incorporated in them. Drawing a Lewis structure would be extremely inefficient and subject to errors such as bad handwriting. Because of this, organic chemists needed a way to draw molecules quickly and accurately. Thus, the bond line formula was created. Since organic chemistry deals with carbon, this formula is tailored to drawing carbon structures. Let's take this molecule, butane, a simple hydrocarbon with 4 carbon atoms and 10 hydrogen atoms. To represent a carbon atom, we'll start with making this little dot, and then connecting them with lines to represent their bonds. Eventually you won't need to draw the dots, and you'll be able to draw them right away. You are probably sitting down right now wondering where our hydrogens went. Well, we don't need to draw them. When hydrogens are attached to carbon atoms, their presence is assumed, and we do not draw them out. Since this carbon atom at the end of our structure already has a bond to the next carbon, we assume that it has 3 more hydrogen atoms connected to it. Any other element included in the structure must be explicitly drawn. For example, if we wanted to add some oxygen to our original Lewis structure attached to the last carbon, our bond line structure would look like this. If we wanted to add a nitrogen onto our second carbon, our bond line structure would now look like this. You can imagine each bend or vertex as well as each end representing a carbon atom. A single line represents a single bond, 2 lines represent a double bond, and 3 lines represents a triple bond. Now let's talk about how organic chemists can use bond line formulas to represent molecules in 3D space. We just used an example of 4 carbon molecule. For this concept, let's simplify it to the most basic organic molecule, methane, or CH4. This is methane in its Lewis structure form. However, it's obvious to anyone that molecules in real life do not exist in a plane of paper. They move around, they have height and width and length. So how do we show that? We like to draw a wedge to show a bond going toward us, or out of the plane of the paper, and a dash to show a bond going away from us, behind the plane of the paper. If one bond is going toward us and one bond is going away from us, the other 2 bonds should be going to the sides, which we'll show with the same straight lines we've been using. This has important implications for our structures. Later, you'll learn how the spatial orientation of specific atoms affects reactivity and stability, but for now, you just must be able to understand where the atoms are located in 3D space. The same rules we just talked about apply to bond line structures. One hydrogen looking toward us, while one hydrogen is looking away from us. No matter how we change the structure using wedges and dashes, you'll be able to understand where the respective atoms are located. Now I understand that this example is not nearly enough practice. Unfortunately, I want to keep these instructional videos as concise as possible. Since we are beginning a new concept, linked to every video from now on will be a PDF with practice problems for the corresponding lesson, as well as an answer key and in-depth walkthrough of every problem by yours truly. I really suggest taking the time to practice the sample problems on your own time, and then compare answers and watch my explanations afterwards. In the next video, we're going to talk about a new concept, resonance.